Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik zit nog steeds, zoals altijd, met...
Jan Stompers, Solution Architect, ACC-ST. Hallo Ronald.
Hallo Jan.
Zo, geweldige dag. Veel mensen. Waar zitten we ook weer?
De Dutch Cloud Native Day in Utrecht.
We kunnen het niet vaak genoeg zeggen. Dus als je wat op de achtergrond hoort, dan hoort dat.
Alleen maar gezellig. But our guest doesn't have that much time, so we're going to switch to English very fast or quickly.
Quickly.
Whatever you want. And I hope I pronounce your name correctly, but normally I asked that beforehand. But
Wait. I see amazing tales. So that promises something.
Yeah, well, keep that suspension high, right?
He has a t-shirt on with amazing tales. Just clarify.
Thank you and thank you for interrupting. Jussi? And then...
That's close enough.
Yeah, Nummelin?
Yep.
Okay. So, could you please introduce yourself and your name in the correct way? I'm sorry.
Okay. All right. So I'm Jussi.
Oh, Jussi. Okay.
Yep. I'm from Mirantis, and I work as a senior principal engineer. Whatever that means. Titles and what you actually do are somewhat different.
Mm-hmm.
So what I actually work on is I lead the team of few developers who are focusing on a couple of our open source projects. The CNCF, Sandbox, K0s, and Cosmotron projects. So basically, my team works on CNCF open source stuff, which is kind of cool.
Awesome.
Yeah.
So, amazing tales.
Oh, yeah. And how did you get started in the IT? What's your background?
Oh.
The Wayback Machine.
Wayback Machine. I think I started around 99 already. My first kind of IT-like job while I was studying. So I was actually working at during my studies at the local ISP provider.
All right.
in their help desk.
Oh yeah.
And 99 internet, they were like grandmas calling us like, help me with my computer, I don't know how it works and I don't know how to turn it on and those kind of things. So it was interesting times per se. Then I got into more into software and development world, and I was an engineer and I'm still an engineer of sorts.
Okay. And can you tell us a little bit about Mirantis? Who is Mirantis?
Right. So we at Mirantis, we're really like a cloud native open source company. What it means is that we're really open source first. So basically whatever we do, it's open source. But of course we have to make a living and money somehow, so we'll sell support and enterprise features and packages and those kind of things. But the core is always open source.
Okay.
And in my specific case, I lead a couple of projects that are really CNCF sandbox projects. So
Which projects are they?
K0s and Cosmotron.
And what then do they do?
That's a good question. So K0s is a kube distro. Very simple, versatile, single binary, which you can drop into basically any Linux environment, and it just works. Super cool for things like edge use cases, which I'm going to actually have a talk here about in about hour and so forth.
Okay, and so that's a small distro, and is it why are you not using Ubuntu Small or Debian Small or Alpine? There's a lot of small distros out there.
Yeah, of course. And K0s is a kube distro, not an OS distro. So K0s can actually run on Alpine or Ubuntu or whatever Linux actually, which makes it super cool. And one of the kind of naming anecdote is that one of the zero aspects is in the name is zero dependencies. It's actually a single binary, statically compiled, so it doesn't have any dependencies.
So you're running your Alpine or Ubuntu Small. That's your own installation. So you're installing Linux, and then you run K0s on that.
No. K0 runs on any Linux. So if you as a user want to run it, you install your own Linux, whatever flavor, whatever way you want, and then you drop in K0s as a single binary, run it, and you have Kubernetes.
Yeah, that's why I was thinking about that. So K0s is Kubernetes in
a single binary.
In the simples.
Yeah.
And how? So the kubelet and the kubelet, you've put the kubelet in single binary. Also the manifests for the API.
Yep.
And are we running then vanilla Kubernetes? Is
Yes.
there something special in that?
It's vanilla upstream Kubernetes always, and that's one of our kind of promises to our users, that it's always going to be vanilla upstream Kubernetes. We're not maintaining any fork. We don't have custom patches or anything. It's always vanilla Kubernetes. It's just, in a very big air quotes, it's just packaged in the simplest possible way.
And the use case is then that it's for edge computing.
Edge computing, or it could be your traditional Kubernetes clusters on whatever machinery, bare metal, even cloud machinery.
Okay.
It's just that it provides a very simple way to manage Kubernetes, because you don't have any dependencies. How do you do update now? I stop it, I replace the binary, I start it again, voila, I'm updated. Right.
So just from my imagination, when there is it K0, K3, and K8. So what are the use cases in this? Because for me, it's like we are getting a lot of flavors now, and why should I use the one over the other?
Right. That's a very good question, and I typically answer that in a way that you have the same for Linux too, right? In Linux, the common denominator is the kernel.
Mm-hmm.
But then you have Red Hat, you have Ubuntu, you have Alpine. So it's kind of like you have different flavors of the ice cream. So you take the one that you prefer and what suits your use case the best, right?
Right. Yeah.
And typically, what I've seen in our user base is that they prefer it because it's super simple to manage and orchestrate your cluster.
Okay. So, in your presentation, you always in the keynote, the first one, you also showed Cordent or Corzero-Dent.
We pronounce it Cordent.
Cordent.
It also has the zero.
Yeah. Okay.
Someone came up with the naming scheme that let's use K0 XYZ all for all the new projects.
Yeah. Okay. So an open source distributed container management, right?
Yeah.
Okay.
Yeah. So it basically we're kind of building on a premise that now we have a K0s, which is super simple way to get and manage your cluster, but it's a single cluster, right? And most of the organizations, they're not running a single cluster. At least they have testing cluster, development cluster, production cluster. And what we've seen is also a big trend to move from humongous production clusters to actually to have lot more and smaller production clusters to kind of manage the blast radius, tackle some of the legal requirements, for example, in banking industry. In banking, there are actual legal reasons where they have to segregate different types of applications to actually different clusters and different infrastructure segments. So voila, you have a problem that now I have to manage like 20, 30, 50, 100, 200 clusters. So that's why Cordon is born. To ease up that task and again, open source, and we're building on top of other open source things, like in this case, Cluster API specific. What Cluster API provides us is like super good abstractions of managing multiple clusters in a Kubernetes native declarative way. So now I can do actually, for example, GitOps, not to manage my applications, but to manage my clusters, which is like a bit mind-boggling in a way.
Okay. And why then Cordant and not Cluster API?
Cluster API is very good at what it does, but Cluster API, because it's a common kind of denominator in a way for all the different cloud providers, all the core Kubernetes ecosystem. So it doesn't have any like opinions in it, right? So with Cluster API, what you get is basically, you get a cluster, but it's an empty cluster.
Yeah.
Now what do you do? Now you have to figure out that, okay, how do I put my CNI in place? How do I put my CSI in place? How do I put my applications, the actual workloads on top of that? And how do I manage all that? And that's one of the areas where Cordant comes in, to manage some of your basic services that you have to have in each of the clusters. We call them usually like beachhead services. Things like CNI, CSI, Prometheus, some log collectors, your observability stack. So Cordant can actually orchestrate that for you automatically. So whenever we create a new cluster, Cordant can actually shove all the needed additional add-ons. Yeah.
And it uses Helm charts?
Yeah.
So can you choose which observability stack or which Prometheus or...
Of course.
You put in?
Yeah, of course.
And how does that work? Cordant just reads a directory of Helm charts?
So basically what you do is you create a concept called service template, which is essentially an Helm chart.
Mm-hmm.
And then you define in your cluster profile, we call it the cluster template. You define it, okay, whenever user creates a cluster based on this template, it'll get this and that service. Right.
Okay.
And then, of course, you can do it the other way around too. You can say that we have this service template, like, say, Nginx Ingress. You can say create a multi-cluster service, which then references that Nginx service. And you can say that let's deploy this to a set of clusters that matches these labels, for example.
Okay.
I see you thinking.
Yeah,
He's picturing everything in his mind.
I'm piecing everything together. So
yeah, we had a talk about Cluster API last week, so I think he's like relating there just to.
I'm using Cluster API myself also, a lot. So Cordant is
It's kind of a layer on top of Cluster API in a way.
Yeah.
If we think about this as a layered sandwich of sorts.
Because we solved it the same way. We're using Cluster API, but we're using pipelines to fill Cluster API and then deploy all the applications on there. And that's Cordant is doing that for us. Yeah. In a way.
In a slightly different way, but essentially the end result is pretty much the same. And of course,
cool.
There's like always in cloud native, there's multiple ways to do things.
Yeah, of course.
Right, of course. Otherwise, it wouldn't be fun.
Yeah, true.
Sometimes I think there's too much.
I absolutely agree. but you could do it even with Cordant. You don't have to use these beachhead services and service templates and whatnot. You can still do the plain old GitOps way. Each child cluster pulling their state from some Git repo somewhere.
Mm-hmm.
Of course, that's totally viable option.
Yeah.
But now you have also a different option that you can do GitOps, but on the management cluster level. So your child clusters don't actually have to do any GitOps themselves. Everything is centrally controlled. So you have like different ways to do things.
And is Cordant then running on the same cluster as Cluster API?
Yes.
Because you've got one central management cluster that is running child clusters as example, and Cordant is running is deploying clusters with Cluster API, but also is managing the applications on that child cluster.
Yep.
Awesome.
Was that the correct terminology? Child cluster?
I'm not sure.
There is another name, I think. What was there?
I think cluster API documentation mostly talks about workload cluster.
Yeah.
That's the one I was looking for.
But-
Exactly.
To be honest, I've always found that term a bit like confusing, like workload cluster. Child
Yeah.
cluster, it's
But it's like the control plane and worker nodes. It's like the same terminology.
Yeah.
I think. Yeah.
yeah.
Okay.
Yeah.
So you also have a talk here. if you have time. So if you can give a quick rundown of your talk, it's called Kubernetes at the Far Edge, Harness IoT with Lightweight Clusters in Akiri.
Yep.
Can you give us a quick rundown of what the talk is about?
So it's kind of like a twofold in a way. So the first part kind of talks that what are the challenges when we are pushing Kubernetes to the edge, and by edge I mean things like running Kubernetes on a, say, Raspberry Pi sized devices, on maybe they're located on some car factory floors, or like really in the edge of the network, like within the reach of like 2G, 3G connections, running some random stuff on some lampposts or those kind of environments. So what are the challenges there in general with Kubernetes, and how we have been solving them, and how our K0 distro can help in that? It's not a silver bullet. I mean, nothing is a silver bullet. So I'm providing kind of like patterns and some ideas how to solve those kind of problems.
Okay.
And the second part of the talk is kind of then, how do we then bridge Kubernetes to what's next, sitting next to Kubernetes, like IoT devices, IP cameras, and those kind of things. And hopefully my live demo works. I actually have a Raspberry Pi with me. I'm connecting it to a camera and running some AI-ish stuff live on there.
Nice.
Let's see how it works.
But you're suggesting to run Kubernetes on IoT machines?
Yep.
And then single node Kubernetes then?
No.
As
It can
nodes
be-
in a cluster?
Yep. In this example deployment that I'm going to show, the Raspberry Pi is actually only a worker node. The control plane is running somewhere in the cloud for me, managed by, surprise, our Cosmotron stuff.
Awesome. Yeah, of course. Of course. And why would you put worker nodes on all IoT devices?
I think the main goal would be to have like a de facto standard way to orchestrate your applications, right? Because your IoT application, I mean, if we forget that where the IoT data and that part comes from, your application is just like it's random-ish code running on a container, right? So you want to have some way to orchestrate that. And if we take the example use case that we worked a couple of years ago, we actually worked on a use case where they have these kind of like industrial controllers sitting on a rack of industrial automation. And surprisingly, those controllers are running ARM CPUs. And we thought that, wait a minute, we can run Kubernetes on ARM CPUs?
Yep.
Can we run Kubernetes on those industrial controllers? Turns out we actually can. And then those applications then can connect to the IoT peripherals and do, stuff. Whatever you do in factories, collect data, control the processes, and those kind of things.
Yeah, because normally I've been around some factories, but they've got PLCs. They're stupid machines.
In that case, we were actually running Kubernetes on a PLC. I have from that use case. Unfortunately, I can't mention the names of those
No, of course not.
factories.
It doesn't matter.
But
that's
I actually have a couple of those PLCs at home with me.
and PLC is something that's stupid. Does one thing very, very, very good. and then it's done.
But you can now inject more logic into that and more applications it's not a traditional application.
No, of course not.
Traditional
It's a PLC
sense,
application.
but
But
you know-
it's awesome.
You can extend the functionality now, which is super cool.
Give me one.
I don't have it with
Of
me,
course.
unfortunately. They're
Yeah.
sitting idle in my office at home.
Well, not to take too much more of your time, we are really appreciated that you are willing to have this chat with us.
I'm super glad to be here in general, and the Dutch cloud native test seems to be super, super, super nice, and I met so many cool people here already, and it's like half of the day only, and
Yeah.
Yeah,
We've
time
got
flies.
we've got one final question for you.
Yeah. So, if I would put a crystal ball here on the table, how would you like to see the future of Kubernetes evolve over time?
I think it's gonna stay. I don't think it's gonna go anywhere. I mean, it's already kind of the de facto standard in a way, but I think what we're gonna see more and more and more is that the Kubernetes is gonna be kind of hidden more and more under different layers of. I'm kind of hating myself saying the word abstractions again.
Yeah. I was waiting for it, otherwise I was saying it.
But the lack of better word, kind of hidden away and more from the day-to-day work of developers, and the other thing I'm definitely seeing already is the rise of Cluster API. I mean, Cluster API has been around for quite a while, but it hasn't seen really the adoption yet. But I think we're now starting to see a lot of adoption of Cluster API on.
And why?
I think it's finally has all the correct abstractions and correct separations of concerns. And it's getting to the level of maturity that it's actually working.
Yeah, I still think there's a lot of improvement there, because for Cluster API you need a working DNS server, you need a working DHCP server, and I think, in my opinion, that's things we could do without.
Absolutely, and I agree that there's a lot of parts where we can improve as a Cluster API community.
Because I was and what I always also think is stupid, because I'm really into that. I've got my Cluster API machine that needs to talk with my hypervisor, but if I roll out a cluster, a worker cluster, that also needs to talk with my hypervisor. And if you install the CPI,
Oh, right.
and you need to install that CPI because it needs to know where the nodes are, because otherwise you can't set a zone for that node.
Yeah. Otherwise, Cluster API can't match the machine object to the node object.
Yeah, and I think, in my opinion, that's stupid, because I don't want to have a worker cluster, that's where my customer logs in, to have access to my hypervisor. And so I've got some things around,
Some improvements.
some improvements, because I try to work around that, and that's not possible.
Yep.
So
That's actually the first bit of a pothole I stepped into when I started with Cluster API like a couple of years ago. I was booting up clusters. I think it was on Hetzner at that point in time. I was just playing around, and I thought that, wait a minute, the machines never get to the running state. What's wrong? And I actually opened up an issue on the Hetzner provider repo, and some of the guys were telling me that do you have your cloud the
CPI.
CPI installed in the child cluster? We're like, no, why would I have it? Like, you have to have it. It's like, okay, thank you. Now I feel stupid.
Yeah, it's if from a management point of view, I think that's not a good idea. But yeah, it works like that. at the moment.
Today it works like that, yeah. Tomorrow, maybe we can figure out a way to
Do something better.
do
But, yeah.
something else, or at least provide an option to do it different.
Yeah.
Okay.
Well,
Thank you very much for the insights.
Thank
And
you for having me.
open source, I like open source. So
Open source first, always.
yeah.
always true.
Yeah.
Well, thanks again and good luck with your talk.
Good luck.
Thanks, guys.
Okay,
You.
see
Nice
ya.
meeting you.
Bye bye.
Bye.